Good morning, my dear students. In this video presentation again, we'll discuss some more problems meant for JEE. It will be useful for anybody who is appearing for any competitive examination, not only for JEE. As I used to tell you, before doing any problem, I'd like to teach you the basic concepts behind that particular problem. For this particular problem which I am going to discuss, I'll tell you two different things. One is explanation about greatest integer function and the property integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. Those two things we'll see. Then the application is there in this particular problem. F or to R defined as f of x equal to box x. Since the box notation is used, I call it as box x, is equal to greatest integer less than or equal to x is known as the greatest integer function. We call it as greatest integer function. Here domain is equal to codomain is equal to set of real numbers, but all the values are integers. Therefore range is nothing but z, set of integers. It is set of integers. Listen carefully. For every x, let us say between -1 and 0, inclusive -1, exclusive 0. For -1 as well as, of course, you mean to say minus 0.99, minus 0.98, etc. nearer to 0, which is minus 0.0.0.1, etc. There are infinitely many integers below that. What are they? -1, -2, -3, -4, etc. Out of which the greatest integer is -1. Similarly, for every x element of 0, 1, it is 0 as well as 0.9, 0.8, etc., etc., etc. Nearer to 1, I have see here value nearer to 1, whatever it may be. You mean to say box value, there are infinitely many integers below that. What are they? 0, 1, -1, -2, etc. Out of which the greatest integer is 0. This symbol is meant for all, either way you can say. For every x element of 1, 2, inclusive 1 and exclusive 2. That is, you mean to say 1.1, 1.2, etc. Here I mean to say 1.99, etc. Here 0.1, 0.2, etc. 0.999, etc. Here 1.1, 1.2, etc. 1.9999, etc. Not exactly 2. Okay. Here it will be automatically box value will be 1. There are infinitely many integers. For any value, infinitely many integers less than or equal to that. What are they? 1, 0, -1, -2, etc. Out of which the greatest value is so. Therefore, you can even say next one, x element of 2, 3, closed interval 2, open bracket, close bracket 2. Okay, for any x element of 2, 3, box value will be 2, and so on. This is how it will go. The graph will go like this. See here, I will mark -1, -2, of course 1, this is 0, this is anyway 2, 3, etc. This is my x-axis, x dash OH, this is my y-axis, y O, y dash. For image for -2 to -1 is -2, -1, -2, -3, and so on. This is 1, 2, etc. But for -1 it is -1, but for 0 it goes up, but for 1 it goes up, 1 to 2, but for 2 it goes up, and so on. It looks like steps what we take for moving up in an apartment, let us imagine. Therefore it's also called step function. The circle which I am going to use, the circle at the right end of every segment will be points of discontinuity, because the image for -1 is 1, not -2. Therefore, this -1, -2 is not there in the picture. It will go up. For 0, it is again 0. For 1, it is again 1. For 2, it is again 2. Therefore, the circles in the rightmost end of every segment will be considered to be a point of discontinuity in the graph. I repeat the whole process. F or 2 are defined as f of x in boxes. The greatest integer less than or equal to x is known as the greatest integer function. Here, this is my domain, that is set of real numbers R. This is my codomain, that is also set of real numbers R. All the images will be integers. Other than integers, nothing will be there in the image. Now, for range will be Z, set of integers. How to think about the images? For every x in the closed interval -1 to 0, close minus and open 0. That is for minus 0.99, minus 0.98, etc. See here, minus 0.001, etc. Nearer to 0, the negative value. Okay, see here. Here I mean to say there are infinitely many integers below that. -1, -2, -3. Out of it, the greatest integer is -1. You use box here, therefore it's called box x. Similarly, between 0 and 1, inclusive 0, exclusive 1. For example, here it is 0.1, 0.2, 0.3, etc., 0.99, etc., nearer to 1, but not exactly 1. There are infinitely many integers below that. 0, -1, -2, etc. Greatest integer is 0. Similarly, box 1 to 2, close 1, open 2, box value is 1. Close 2, open 3, the interval, box value is 2. Now for image, for -2 to -1 it is -2, but for -1 it goes up, but for 0 it goes up, but for 1 it goes up, but for 2 it goes up, and so on. It goes further. Every circle in the rightmost end are considered to be points of discontinuities. There are infinitely many points of discontinuities here. -1, -2 is a point of discontinuity. 0, -1 is a point of discontinuity. 1, 0 is a point of discontinuity. 2, 1 is a point of discontinuity, and so on. It looks like step stack in staircases we use, therefore it's also called step function. It is also called step function. It's not at all difficult to follow. Okay, I hope you are able to follow. As I already told you in earlier videos, I will teach you the concept behind every other problem what I am going to discuss, and wherever possible I'll tell you the shortcut method also. Wherever possible I'll tell you the shortcut method, how to go about the easier way of getting the answer, etc. It's not possible in every other case. Almost in 90-95% cases will be able to apply the shortcut method, but don't learn only the shortcut method, learn the concept behind each and every problem. They'll be very useful. It will be very useful always. It will be very useful. If you remember the concepts, you'll be able to apply your mind easily. Just listen carefully. The next, your integral result. Integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. That is, if I interchange the upper limit as c is as equal as adding integral c to b f of x dx. That is the meaning. Proof is very simple. See here, let integral f of x dx is equal to g of x. As indefinite, I call it as g of x. Therefore, you mean to say integral a to b f of x dx can be written as g of x a to b. I have to apply upper limit, I have to apply lower limit. What I will do is, I will subtract g of c and add g of c. I need it, therefore I do. This can be written as g of x c to b plus this is g of x, let us say a to c. Upper limit here is b minus lower this much. Now this is equal to c to b f of x dx. Practically speaking, this is nothing but a to c f of x dx. If I write this is the beginning, that's the way it is being done. But only thing what you are supposed to remember here is the value c need not be between a and c. I'll give explanation for that. Remember carefully. Okay, I will just take a method like this. This is my a, this is my b, this is my c initially, let us say. Okay, let me just mark the points over here. A, B, C, D, E, let us say F here. Practically speaking, the geometrical meaning of definite integrals tells you integral a to b f of x dx is the area of the line x equal a, the curve y is equal to f of x, this is my y is equal to f of x, line x equal to b, and x axis. That's the real meaning of it. Now for integral a to b f of x dx, the area here will be AB DE. This whole area can be written as ABCF plus area FCDE, which is nothing but A to C f of x dx plus C to B f of x. That's the explanation. When C is in between, then C is in between A and B. Okay, let me just imagine C is to the left of A. Let me just find out C is to the left of A. Okay, just see here. This is my A, this is my B, this is my C, let us say. Let me mark the points as usual. A, B, C, D, E, let us say F, G, let it be. Okay, C is already written here. Now, A to B can be written as area, C here, FC, DE. C here can be written as area ABDE minus area ABCF. This is how the whole area minus this area we can write. This is nothing but integral C to B f of x dx minus integral, this is anyway C to A f of x dx. Now here if I interchange the upper and lower limit, I'll get it to be plus. If upper and lower limits are interchanged, I'll get a negative sign. Therefore, plus A to C f of x dx, same as A to C f of x, C to B f of x dx. It's very simple to follow. It's very simple to follow. It's not at all difficult. Similarly, let me take the third possibility. Let me take the third possibility. C lies to the right of my A is here, B is here, C is to the right of B, let us say. Let me mark the points as usual. C, D, E, F, let us say. Now integral A to B f of x dx is nothing but here area, what is it exactly? ABCF can be written as area ABDE, see the diagram, minus area CDEE, sorry, CDEF, CDEF, the whole area minus this can be written as, this is nothing but A to C f of x dx, minus this is nothing but, see here, A to C, this is my A to B, sorry, this is A to B. My point, what is my point practically speaking? This point is different. This is capital C. Don't get confused, sorry. Here it is A to C f of x dx minus B to C f of x dx. But if I interchange the upper and lower limit, I'll get plus B to C, A to C plus C to B it will be. I'll have minus sign if it interchange the upper and lower limit. For A to C f of x, C to B f of x dx. Therefore, I come to the conclusion, whenever I am going to apply such a rule, your point C need not be always in between A and B. It can be in between A and B. It can be to the left of A. It can be to the right of B also. By looking at the diagram, you will be able to get the result. By looking at the diagram, you will be able to get the result. In fact, I have proved on this thing. If I interchange the upper lower limits, it is nothing but you have a negative sign, that is integral A to B f of x dx is equal to minus B to A f of x dx. This is also a simple proof. Let f of x dx is equal to g of x. Therefore, integral A to B f of x dx is equal to g of x A to B can be written as g of B minus g of A, can be written as minus of g of A minus g of B, can be written as minus of g of x B to A, can be written as minus integral B to A f of x dx. Therefore, if I interchange the upper and lower limit, it will be nothing but there is a negative sign in the final answer. That is also used in two of the cases earlier, okay, in this particular video itself. Now what I am going to do now is find or evaluate, either way you can write, it will be minus 1 to 1, you mean to say x minus box x dx. Okay, this can be written as minus 1 to 0 x minus box x dx plus integral 0 to 1 x minus box x dx. Remember carefully, instead of A I have minus 1, instead of B I have 1, my C is 0. I can very well write. And between minus 1 to 0, this value is minus 1. Just now we have seen between minus 1 to 0, box x value is minus 1. We have seen just now. Here it is between 0 to 1, it is simply 0. Therefore, I end up with x square by 2 plus x minus 1 to 0 plus x square by 2 0 to 1. For apply upper limit 0 plus 0, then apply lower limit, it will be minus of, sorry, I have used bracket unnecessarily, just see here, I mean to say minus of, apply lower limit, I mean to say half minus 1 plus this will be anyway half, half minus 0. Therefore this is reduced to anyway plus half, which is reduced to 1. Answer happens to be 1. Let me just repeat. Integral minus 1 to 1 x minus box x dx, or you can very well write f of x dx, where f of x is this much. I'll split it as minus 1 to 0, this value, plus 0 to 1, this value. We can put this in brackets also if you want. Okay, again we put it in bracket. Okay, here for any value between minus 1 to 0, box x is nothing but minus 1. For any value between 0 to 1, box value is 0. Therefore this gets reduced to x plus 1. Integral x plus 1 is x square by 2 plus x minus 1 to 0. Here it is with x square by 2, 0 to 1. Apply upper limit 0 plus 0 minus lower limit. Minus whole square is 1. 1 by 2 minus 1 plus half. This is minus of is half. Now the final answer happens to be anyway 1. Final answer happens to be 1. So since I have given too many proofs for your convenience, I took almost 16 minutes. Let me check the video once again. If there is any correction, I'll correct. Otherwise, I'll upload as it is. Thank you, students, for patient watching.